Okay. So it gives us a setup. So I think we got to go through. How many steps is our process on these guys? How many steps do we need to go through? 3, right? Maybe three or 4. So I think the first part was, what's the relationship that's being described? So inversely is the relationship. So what's varying? G. So G equals. We know there's always a K. I hear people saying K. Awesome. K over. Yeah, because it's inverse, right? Over what? So I don't need that. I know like square root of x. Right? So it's square root of x. Hey, there's a relationship done. Step 1. Step 2 was they prime measured that relationship in a special set of circumstances. What are the measurements they came up with? So they said 2 was G when x was 49. So that'll let us find that special constant of variation. So what is it? Squared 49, we know nice. 7, so I'm going to go like 2 is K over 7. How do I get K in that? That, right? So what is K? 14. So then if you remember, the next part, so you don't get confused, is write down the specific relationship. Those measurements were for our specific scenario, so they're going to turn this into specific G equals 14 over the square root of x, and now you can use it for whatever they ask you to do. So I'm telling you, if you stick to the process, you won't have any issues. They said a couple different things. Find a G when x is 169. Okay, so I'm going to put in 169. What is square root of 169? I think we know that. 13. Oh, G is 14/13 in that situation. Done. So I answered that question. I think I asked one more question. Because I think there were other problems that said more in general, more abstract. What if x is tripled? What would that do to G? What would the effect be?
X is going to get little. X is going to get little.
Okay. Well, let's find it exactly how little if you're thinking that early. So I'm just gonna. I think I could use the general. Let's just pretend we never found the specific relationship in this situation. We could use that too, though. Most of the ones I gave you don't have measurements. You can't use it. So what am I supposed to put in here?
169.
I just want to know if x is tripled.
Oh, so you got a triple x to see.
You got a triple x to see that, so do it. Triple x. I remember, I think we were supposed to say that this was like the new G. Now, I think that the idea, if you remember, was when you do one like this, you look for the old G in the new G. You guys see the old G in there? Can you see the elements? I see it. I think it's like right there, isn't it? That's old G. So simplify. I think you have, can square roots go like this? I think they can. I guess I'll work on that more next chapter, but I think you can do that with square roots. If there's a plus in here, can you do that?
No, wait.
No way. You're right. You can't do it with a plus. But you can do it with multiplication or division. You can do that. So now I think that we've got G prime is, I can put a 1 here, and there is the old G. So Herlin said he thought it got smaller. I think he was right. That says exactly how much smaller. So now I can just write this in words. So I could say this says that the new G, G prime, is the old G divided by what? Divided by the square root of 3x. I could write that like same thing as G divided by the square root of 3. Or multiplied by 1 over the square root of 3, however you want to say it. Okay, so there's another one just like that. I think that's all you have in the variation thing. Like that covers pretty much of it. So use the videos if you need to on those.